Coming back at you. Quick algebra review, and then we're going to tie it into some geometry. Let's get started. Our key concept for today right now is slope. Right now, here's our slope. All the words explaining it. Simply stating this formula right here. You've used this in Algebra 1. Keep in mind, subtract the y's on top over, subtract the x's on the bottom. Slope, rise over run. Four possible scenarios when calculating slope. Going from left to right, you can have positive slope. Going from left to right, you can have negative slope. You can have zero slope, or you can have undefined slope. Remember that, folks. Now, let's look at some examples. Plug them in. Real simple. Find the value, find the slope through the points -3, 7, and -1, -1. First, I write down my slope formula. y2 minus y1 over x2 minus x1. Remember, subscripts just tell us the difference between the first and the second points. So, label them. x1, y1, x2, y2. Now that you're labeled, real simple to plug them in. y2 minus y1, -1 minus 7. Over x2 minus x1, -1 minus -3. -1 minus -3. Biggest mistake with slope, positive negative numbers. -1 minus 7 is -8. Over -1 minus -3. Minus negative. Plus positive. So -1 plus 3 is 2. Simplify it. Always simplify your slopes. It's going to come in real handy later. I like to keep my slopes as ratios, so I'm going to end up with a -4 over 1. Boom. Example 1. Done. That's a negative slope. Example 2. Calculate slope again. y2 minus y1 over x2 minus x1. x1, y1, x2, y2. Plug them in. y2 minus y1, -3 minus 4. Over 0 minus 0. -3 minus 4. Over 0 minus 0. Sounds kind of tricky. Notice I have a 0 in the denominator. Can you divide by 0? No. This is an example of undefined slope. If I were to plot these 2 points, one would be right on top of the other. It's a vertical line. Please do not ever write no slope, because if you write no slope, do you mean undefined or do you mean 0? Example 3. One more time. y2 minus y1 over x1, y1, x2, y2. -1 minus -1. -1 minus -1. 6 minus -2. -1 minus -1. Again, you can change that to plus positive. That is 0 over 6 minus -2. 8. 0 divided by 8. 0. This is a 0 slope. Again, do not write no slope. I don't know if you meant undefined or 0. You either write undefined or put slope is 0. Now, let's take this and tie it into geometry. We were just talking about parallel lines, and now we're going to tie it into parallel lines and perpendicular lines. Parallel lines, real simple, folks. If you calculate the slope of two lines and their slopes are equal, they are parallel. They have the same slope. Parallel lines have the exact same slope. This is why it's important to reduce our fractions to make sure they're the same. Perpendicular lines. Now if you read this, it sounds a little more confusing. Let me simplify that for you. Two non-vertical lines are perpendicular if and only if the product of their slopes is equal to -1. Very important here, vertical and horizontal lines are perpendicular. But let's look back at this. The product of their slopes is -1. How does that happen? Well, the simplest way to put perpendicular lines, I'll write it right underneath. Their slopes are opposite reciprocals. Opposite reciprocals. One's positive, one's negative. Reciprocal. You take the fraction and you flip it. That's why I like to keep my slopes as ratios. Okay? Opposite reciprocals for perpendicular lines. Notice right here, this one has a slope of 4. Well, it's not a ratio, but if it was 4 over 1, change the sign, so this is positive, now it's negative. Flip it, -1 over 4. Opposite reciprocal, so a slope of 4 and a slope of -1/4 would be considered perpendicular. Now, just like the first 3 examples we did, find the slope, but now I got to do it twice because I got to determine if they're parallel, perpendicular, or neither. So here's my formula. Here's my first one, line FG. So here's my first slope. I got to calculate, and line HJ. Here's my second one. I'm going to do the slope for FG right underneath it. The slope, y2 minus y1. y2 minus y1. -1 minus -3 over -2 minus 1. x2 minus x1. -2 minus 1. -1 minus -3, 2. -2 minus 1, -3. So the slope of FG is -2/3. Slope of HJ, 3 minus 0 over 6 minus 5. 3 minus 0, 6 minus 5. Now, are they parallel? Are these the same? No, so they're not parallel. Are they opposite reciprocals? Well, this one's positive, this one's negative. But if I take 3 over 1 and flip it, do you get 2 over 3? No, so these are not perpendicular either. These lines are neither. Example 5, doing it all over again. y2 minus y1 over x2 minus x1. Why do I keep writing the formula over and over again? That's how I memorize them, folks. I keep writing them, then they stick in here. Slope of AB and the slope of CD. Let's find the slope of AB first. 5 minus -1 over 4 minus -2. Solve or simplify. Five minus -1. 6. 4 minus -2. 6. Oh, what does that reduce to? Again, I'm going to leave it as a ratio. Slope of CD. -2 minus 1. -2 minus 1. 9 minus 6. -2 minus 1. 9 minus 6. reduce. There's my second slope. Now, again, are they parallel? Are they exactly the same? Perpendicular. Are they opposite reciprocals, or are they opposites? Negative, positive, yep. If I take 1 over 1 and flip it, do I get 1 over 1? Yeah. So these lines are perpendicular. That's it, folks. Parallel lines, exact same slope. Perpendicular lines, opposite reciprocals. That's it for the lesson. Thanks for watching.